Hello everyone, welcome to the solutions for BStat and BMath questions from ISI 2024. The exam has just finished and we are trying to bring you the solutions as fast as we can. We had discussed question 21 before, and now for our set we are at question 24, right? So how would we solve this question? Now question 24 deals with prime numbers and squares. Alright, so this is a question from number theory, although there is not much traditional number theory behind it, but we can still apply the elements there, and after that we can apply our basic knowledge of factors, divisions, and general mathematics. Alright, so you cannot classify this sum as any particular chapter, but if you tell that this is a sum of general mathematics, fine, people will agree to it. Alright, so let us see how to solve this. Now what is said here? We are told that p is less than q. Fine, both of them are prime, then p square plus q square plus 7q is a perfect square, right? So once we have that information, then we can assume that p square plus q square plus 7pq would be equal to a certain k square, right? Because if this is a perfect square, this is bound to happen. Alright, now once this happens, I can manipulate this algebraic expression, right? So I can write here p square plus q square plus 2pq equal to k square minus 5pq, right? I can do that, and in fact I can put 5pq there and have k square minus p plus q whole square, right? So once I do that, I'll have 5pq equal to k plus p plus q into k minus p minus q, right? A simple factorization that should do it. Now how do we extrapolate the answer from here? Now here we will look into k minus p minus q. We'll looking into the positive part, alright, because we do not know the value of k and p and q. So instead of that, we'll look into just the positive part. So for the positive part, we can have 4 cases, right? So case 1 would be k plus p plus q can be anything among 5pq, right? So this is the multiplication, so this can be q, right? If this is q, then k would be equal to minus p, and that is not possible, right? So this case is eliminated. Alright, case 2, k plus p plus q could be equal to p, right? Because it is 5pq, so I'm going one by one. Then k equal to, sorry for the typo, then k would be equal to minus q, right? Again, that's not possible because k is a square number, right? I cannot have it as a negative of a number. Alright, then case 3 I can mention k plus p plus q, that could be equal to 5, right? Now think, p and q are primes, right? Therefore p comma q both will be greater than equal to 2, and p is strictly less. So if p is 2, at the least if p is 2, then q should be 3, right? This is the least case. Then k will become 0, right? So again, that is not possible. Alright, now we have checked each individual case. Now we can consider them together, right? So if k plus p plus q equal to 5p, alright, then k minus p minus q, that portion should be equal to q, right? So maybe we can solve these. So if we eliminate k, what will you obtain? Try to eliminate k, it will be from here I'll have k equal to 4p minus q. From here we will have k equal to p plus 2q, right? If we combine this, we are going to get twice of p, right? I'm just eliminating k, nothing super special. Twice into p plus q, this will be equal to 5p minus q, right? And then if we solve this, we will get p equal to q. So once we have that, then here we have p equal to q, and then k plus p plus q equal to 5p, right? So what is the solution that we are getting from here? The solution we are getting from here is k, if I have another constant, so k will be equal to thrice of p and p equal to q, right? So a solution might be of the format pq, k might be of the format m, and 3m, right? We get a integer solution, but the problem is we have p less than q, right? So we cannot include this. Our answer will not come from here. So this is gone. Okay. Next case. So similarly, if I take k plus p plus q equal to 5q, right? If I just do the opposite one, let's say this is 5q, and then k minus p minus q equal to p. You do the same steps, right? I'm not showing you the steps because you do the exact same thing. If you do that exact same thing, you will get the exact same solution. Alright, so again you will have m, 3m type of solutions, although this is integer solution, right? But integer solution does not imply that p less than q will be satisfied. So again this is unacceptable. Alright, C6. So what is the sixth case here? Sixth case is if I take k plus p plus q equal to pq, and then k minus p minus q equal to 5, right? How are we going to talk about this case? Now for this particular case, we have to solve it again by removing k. So if we remove k, we will get twice of p plus q, right? Just write here removing k, right? You can do that removal part in the rough section. Just write here directly twice of p plus q, that should be equal to pq minus 5. Alright, now here we have a term in pq again. So if we factorize that, you will get p minus 2 into q minus 2, that will be equal to 9. Alright, so factorize it from there. Now once we have this, here we have certain set of solutions. Alright, so p minus 2 into q minus 2 equal to 9. And what integer solutions can we get here? So let us quickly eyeball it. So p comma q can be equal to, I think, 5 comma 5, because 3 into 3 is there. Then 9 can be factored into 1 into 7 and 7 into 1, right? So neither of them would work. But I can also take something that is more than 9 and then bring it back to 9. So something like 3 11 and 11 3, that would work, right? Because then I would get 1 into 9 and 9 into 1. Alright, because if I start with 1 into 1, then 1 into 9, then I'll get minus 1. So that is not the case. So therefore, what are the solutions of p, q, k from these sets? So p, q can become 5, 5, and then k would become, just check from here, k would become 15, right? Thrice. Alright, and then we could have 3, 11 and 19. Alright, that is a solution. Or we can have the last case. We will be obtaining 3, I'm sorry, instead of 3 11 19, we'll obtain 11 3 19, right? 11 3 19. Now how many of these cases are acceptable to us? P is less than q, right? So this is not acceptable, this is not acceptable. So the only solution that we are left with here is for p less than q, we have 3 11 19 for p, q and k. That means the maximum value of q we obtain is 11. Alright, now this sum was a bit larger. We had to consider each case separately, and then we had to evaluate each case, and this condition that was given of p less than q made it much more easier, right? If there was a condition of p less than equals to q, nothing would have changed. We would have still gotten 11, right? I have seen this sum in different places. Sometimes they ask you to find all sets of integer solutions, how many will be there. Alright, that is also a different question. So if you are appearing for any other exams and you need any crash course, you can look into the numbers that are given below in the comment section, and we can help you there. Alright, these type of questions are usually solved in our classes. So if you need any help, do contact us. And if you have any problems relating to this solution, please rewind it and watch it slowly. You will understand. Alright, I have done all the steps. Some of the steps I've skipped because those are trivial, right? You are appearing in ISI exam, you are supposed to do them on your own. Okay, you can do them on the rough sheet and then write it here directly. Alright, I have shown you the complete subjective solution so that if somewhere in down the line in the future this question is present in the subjective section, then also you would be able to answer it. Okay, so I'll be ending the video here. Again, if you need any help, do contact the numbers in the given below.